Alright, here is day 2. Day 2 has to do with the inverse of what we did on day 1. We are solving log functions, so these are functions that have logs that we're trying to get rid of so that we can solve for x. The x is trapped inside the log this time instead of being trapped in the exponent. So if you look at the reminder up here, this is just reminding you how to change a log into an exponent. If you remember, logs are my bay. So that's the first method I'm going to show you in number 1, and then I'm going to give you a second method. So in number 1, we could literally look at it as how do I rewrite the equation. So the little 2 would turn into the base of the equation. This is base, this is answer, this is exponent. So then the 3 would turn into the exponent, and the part that was in the log turns into the answer on the other side. And then all you have to do is solve that, which actually, if you look at it, it's kind of an easy problem. You just have to do 2 cubed, which is 8. You get 8 is equal to x minus 4, and then you have to add 4 to the other side. And you get x equals 12. So that's one way to get your answer. And that one's pretty straightforward. That way some of them get a little bit more complicated, and that's why I like to use this second method. So in the second method, if I rewrite the problem, it's literally thinking about algebraically, what do I do to cancel out the log? That's what's on the outside of the problem, that's what I gotta get rid of. So to cancel out a log base 2, I have to make the whole problem have a base of 2. So when I do that, this is a base of 2, and everything else is an exponent. So that's what you have to remember when you do that, though. You're taking everything else and you're raising it up. Because these end up canceling, if you remember back what we did earlier this chapter. We get x minus 4 is equal to 2 cubed, is really what that says. So that's x minus 4 equals 8. Add the 4, x equals 12. Alright, let's look at number 2. It's a little different because it has a natural log, so things are going to have to happen a little differently here because it's a natural log. But the first step is to isolate the natural log. We're trying to get rid of what's on the outside of the problem first. So we would divide first, we get 2. And then to get rid of the natural log, you have to remember what the opposite is of the natural log. The opposite is, hopefully you're saying e, we're going to have to use e as the base. So that e is going to become the base of the problem. Everything else turns into an exponent. The e and the ln cancel on the left-hand side, so we have 3x is equal to e squared. That 2 is really now the exponent of the problem. And then divide by 3. So we get x is equal to e squared over 3. You're going to see that as an answer in the back of the book. And then you're also going to have the decimal approximation. So if you type that in your calculator using the E button, and making sure the divided by 3 is on the bottom, not in the exponent. So probably use the fraction button. You get 2.463. That's your answer. Alright, let's look at the next one. Again, the idea here is unwrap. So we're going to subtract 5 first. 2 ln of x equals 8. And again, outside, get rid of the outside part first, divide by 2. The natural log of x equals 4. And then we have to get rid of the natural log. To get rid of the natural log, we make the base of the problem e. These guys are going to cancel. We get x is equal to e to the 4th power. That's really an exponent. Make sure you remember that's an exponent. And then we type that in, and we get an answer of 54.598. I think the back of the book only does 2 decimal places, but for some reason today I'm doing 3. But you can feel free to round to whatever the book says. Alright, the next 2 get a little bit more complicated. The problem with these next 2 is that there's 2 logs in the problem. We can't undo the log until there's only one of them to undo. So this note over here is really important. You need to combine the logs before you can cancel anything out. So if I want to combine the first logs when it says plus, You have to remember this from earlier this chapter. When it says plus, we multiply the logs together to combine them. So this is going to be log of x times x minus 3 equal to 1. And then our goal is to now get rid of the log. And this one is again a little different because it's the regular log. You have to remember that log log by itself really has a base of 10. So now to cancel out the log, I make the whole problem have a base of 10. When the logs cancel out, this is x times x minus 3 equal to, this is really 10 to the first power. 10 to the first power is just 10. Then you have to work on solving this. So we have to distribute first. X squared minus 3x equals 10. Subtract the 10. We're going to get x squared minus 3x minus 10 equal to 0. Then hopefully your brain is telling you have to factor. We're looking for factors of negative 10 that add to negative 3. It's negative 5 and 2. X minus 5 times x plus 2 equals 0. And then we have to solve it. X minus 5 equals 0, x plus 2 equals 0. We get x equals 5, and x equals negative 2. The one thing you have to do here is you have to make sure you check for extraneous solutions. Because the rule is, what we learned yesterday, is that you cannot plug in, you can't take the log of a negative number. So if anything that they've given us, if we plug it into the problem and it's going to create a log that's negative, it can't be an answer. So if we put the 5 into both of the x's up here, that's a log of 5 and log of 2, that one's going to be fine. You can type it in your calculator and make sure it comes out right. It'll tell you that you did the right answer, but that one should work. But when I put in negative 2, it's going to say log of negative 2. This one can't work because the answer, the calculator can't evaluate it. Okay? So you need to check it in your calculator, plug it in. I'm not going to go through all those steps. You can plug it in even with the equal sign and see if it works out, and it should work out. Alright, for number 4, we have to look at first combining the logs. We can't solve it when the logs are separated. We need to get them together first. So to get those together, at subtraction, we're going to have to divide. So it's going to be log base 4 of x plus 2 over x minus 4 equal, or x minus 1, sorry, equal to 1. So we divide them to shove them together. Then now the log is on the outside of the whole problem. So to get rid of the log, I'm going to make the base 4. So it's a log base 4. I need to put a base of 4 to cancel it out. Those cancel it out. We get x plus 2 over x minus 1 equal to, this is really 4 to the first power, which is just going to be 4. And then we have to solve it. So to solve it, if you can't see what to do right away, my suggestion would be to write both of them as fractions, make it 4 over 1, and then all you're doing here is cross multiplying. It's x plus 2 equal to 4 times x minus 1. X plus 2 equals 4x minus 4. 3x is equal to 6 when you move stuff around. Divide by 3. X equals 2. And you should be able to plug that in and check it and make sure it works. Okay? So do your best with this, and we'll talk when I see you next.